Okay, so let's look at an example using the squeeze theorem. And let's say we want to find the limit as x is approaching 0 of, let's say, x squared cosine of theta. And we're not sure what's going on here. And we want to use the squeeze theorem to help us. So let's look at some things that we know. And so let's talk about our function cosine of theta. If we remember cosine of theta, that was our wave, and that range was between -1 and 1. We started at 0, 1, and then we came down. So hopefully you agree with me that cosine theta, that value is going to always be bigger than or equal to -1, and it's going to be less than or equal to 1. Okay, so that's a true statement. And now let's look at this, and maybe instead of, I should have probably said x instead of theta. They should be the same variable. Okay, so remember rules of inequalities? We can multiply an inequality by a positive number, and it would keep the direction of the inequality itself. And so we could multiply this inequality here by x squared, and this would still be a true statement. And again, we have to say because x squared is always greater than or equal to 0. We multiply by a negative number, recall that changes the sign. And so of our direction of our inequalities. So now we can say that this is the same as, now multiply through, I'm just going to mute you guys. This is -x squared is less than or equal to x squared cosine of x is less than or equal to x squared. Well, we know what's happening to the limits here. And we know that the limit as x is approaching 0 of -x squared, right? That's if we looked at it graphically as a parabola facing downwards. That's going to 0. We can also say that the limit as x is approaching 0 of x squared, which is just a parabola facing upwards, is also equal to 0. And because we can say that, so the limit as x approaches 0 of this -x squared is going to be less than or equal to the limit as x is approaching 0 of x squared cosine x, which is less than or equal to the limit as x is approaching 0 of x squared. Again, we know that this is 0. This is less than or equal to limit as x goes to 0 of this x squared cosine x. And we just said that this was also 0. So therefore, we can say that the limit as x approaches 0 of x squared of cosine x is also 0. So depending on your instructor, and I know my husband uses a lot of notation, mathematical notation, these kind of 3 dots that kind of form a triangle means therefore in mathematics. So therefore, we can say that the limit as x approaches 0 of our function x squared cosine of x is also 0. By the sandwich theorem, and then a lot of times when you are finished showing something, you'll see that square at the bottom. That basically means that you're done showing what you're trying to show. Although we really weren't proving, we were just using the theorem to find the result of that limit. Okay, so I want to just do one more example. When you're doing the examples from the book, right now they're giving you the values, what to bound, what functions to put on the left of the one that you're looking at and which function to put on the right. And so this says use the sandwich theorem. So this is an example. And it says if the square root of 5 minus 2x squared, given that this is less than or equal to f of x, and this is less than or equal to the square root of 5 minus x squared, and this is only, that is only true for -1 is less than or equal to x, which is less than or equal to 1. And they want us to find the limit as x approaches 0 of f of x. Okay, so let's just take the limit as x approaches 0 of our function on the left and the one on the right. And so I'm just gonna, let's just write it all out. So limit as x approaches 0 of the square root of 5 minus 2x squared is less than or equal to the limit as x approaches 0 of f of x, which is less than or equal to the limit as x approaches 0, again, at the square root of 5 minus x squared. Okay, so by the limit laws that we learned the other day, and we talked about using direct substitution, that's what we always want to start with, and it's not rational, so we're not going to get something as 0 over 0. So we're going to go in, and we're going to plug in 0 wherever we see an x. And so looking at the limit on the left, I'm going to drop the limit because I'm plugging it in. I have the square root of 5 minus 2, put parentheses, and then square that parentheses. And keep it as a limit as x approaching 0 of f of x. And then I'm going to do a direct substitution for this limit on the right, farthest right. So plugging in 0, I get square root of 5 minus 0 squared. Well, simplification underneath the radical first, we have 5 minus 2 times 0 squared. 0 squared is 0, times 2 is 0. So we get the square root of 5. It has to be less than or equal to the limit as x approaches 0 of f of x. And again, we can simplify underneath the radical, and we are left with the square root of 5. And therefore, by the sandwich theorem, we can say that the limit as x is approaching 0 of f of x is equal to the square root of 5.